Hey everybody, Justin here. Thank you for checking out this video. In this video, I wanted to share just some basic statistics ideas. And I'm going to do this kind of experiment with this Tic Tac box that's unopened. And I just thought, hey, what can we say about the red, yellow, green, and orange Tic Tacs in here? What would be, kind of ideally the question would be like, what's the probability that I get one of these, I reach in, and what's the probability that I grab a red Tic Tac, for example? We could try to answer questions like that. So the first thing is, I bought this at the store, somewhere between $1 and $2, I'm sure, and unopened, and I'm just going to empty the contents out, and I have this little table I drew. I'm just going to count the number of red, yellows, green, and orange, and then just, I'll have a total count. And I'll divide each count by the total count and get a percent over here. So that's what I'm going to do right now, and then I will fill in the table and get back to you. So let me go do that now. Hey everybody, I am back. So you can see these colors here now are like more stratified, right? Because I counted the yellow first, then the red, then the green, and then the orange at the top. So I counted these, and here are the results. So 17 red, 17 yellow, 18 green, 8 orange, so 60 Tic Tacs total. When I divide, 17 divided by 60, I get about 28%. For the green, it's about 30%, and the orange is about 13%. Now, if you add all these up, you're not going to get exactly 100. You'll get 99 point something or you'll get 99 because this is like 28.33. This is like 13.33. So I just rounded, that's good enough for this. So we can answer the question, like, what's the probability that when you buy one of these, Tic Tac fruit adventures, that if you reach in randomly, drawing out one red Tic Tac would happen about 28% of the time. But I'm not stating that as like a universal truth. There's uncertainty involved with this, right? I don't know how they make these Tic Tac boxes. It could be different for many of them, but this is at least some evidence, right, of that. So what I wanted to show with this is, and maybe you can anticipate it because there's all this extra space over here, is that really in science and statistics, you need to replicate. You need to replicate things because one experiment, no matter how well designed, how well funded, is not very conclusive, right? So what I have here, you can hear it, is two more unopened Tic Tac boxes. So I'm going to do the exact same thing and fill out a table like this, just right over here, box 2, box 3. And then after that, I will sum the counts across the boxes. So however many reds I get from box 1 will be added to how many reds I get from box 2 will be added to how many reds I get from box 3. That replication is super important because it tells you in these independent, these boxes are presumably independent from the other one, in independent experiments, kind of what the state of affairs is. And you can use, they kind of call it sometimes meta-analysis. You can analyze all those experiments as one and get a better situation of what's going on. So I'm going to, again, pause this, and I will come back with the results filled out for box 2 and box 3, and we'll go from there. So I'll see you in a second. Okay, everybody, I am back, and I filled out the information for box 2 and box 3, and then I have an overall. So let me just go through and explain some interesting observations that stood out to me. So the first thing we can see is in each of these Tic Tac boxes, there's 60 total Tic Tacs. So it seems like I could infer that they probably standardize the amount that goes into each Tic Tac box or container, whatever you want to call it. The second thing is the number of orange seems to be the same, 8, 8, and 8. So I thought that was pretty interesting, that the number of orange seems to be a constant, whereas the others are slight variation. You had 17 red, then 13, and then 17. Yellow, 17, 16, 20. Green, 18, 23, 15. So that seems to have some variation, but the orange, at least in these 3 samples, seem pretty fixed. Now again, at the end of the day, we only have 3 samples or 3 experiments. We could easily do this, spend a couple more bucks, and maybe we get 7 more boxes and we get 10 different replications of this experiment. And again, what I did for the overall is I just added these together. So I added 17 plus 13 plus 17 red to get the 47 red, 17 plus 16 plus 20 to get the 53 yellows, and so forth. And then 60 in every box just gives 180 total. And so I would feel much more comfortable using this overall numbers if you ask me, what's the probability of getting a red in these type of fruit adventure Tic Tac boxes? And I could say, oh, with some confidence, 26% of the time that would happen. Now you could do fancier statistical things and put maybe more of a measure of uncertainty on this using a confidence interval type of approach. But I just wanted to keep it very simple and just to show that if you do something one time, you do have some information, but it's not the end of your information. It's just the start. You need to replicate that basic experiment or survey a couple times to get a more, more realistic numbers. Okay. So that's what I wanted to share in this video. And that is all I got. So I'll see you next video. Thanks for watching. Bye-bye.